Good evening, ma'am.
Good evening, sir. You can continue, sir.
Yeah. Good evening to all.
Good evening, sir.
Yes. Yesterday we did with the second colligative property. Today we will do the third colligative property, that is elevation in boiling point or ebullioscopy. Let's see how fast we can complete with this and go for the next colligative property. All right. Now, the property what we're going to learn is called as elevation in boiling point. This elevation in boiling point is also called as increase in boiling point. Elevation means what? Increase. Increase in boiling point of the solvent, and it's also called as ebullioscopy. It's also called as ebullioscopy. What is this elevation in boiling point? We will define what is elevation in boiling point a little later. First, we will try to understand what is boiling point. What is boiling point? How do you define boiling point? The temperature at which the vapor pressure of a solvent becomes equal to the atmospheric pressure is called as boiling point. What is boiling point? The temperature at which the vapor pressure of any solvent becomes equal to the atmospheric pressure is called as boiling point, atmospheric pressure. Now, for an example, if I take a container, in this container, we take water. In this container, we take water. Water has a tendency to vaporize even at room temperature. Water has a tendency to vaporize even at room temperature. Now, there is water vapors. This is water and this is water vapors. Now, I told you water has a room, ability to vaporize even at what? Room temperature. Now, now when a cool breeze blows across, what happens is there will be a condensation of these water molecules, water vapors to form water molecules. There exists an equilibrium. So at this condition, with the pressure exerted by this vapors is called as vapor pressure. Now, I told you water has a tendency to vaporize even at room temperature. At room temperature, the water vapor pressure, what you measure, will not be equal to the atmospheric vapor pressure. Will not be equal to atmospheric vapor pressure. But when you boil water for 100 degrees, at around 100 degrees Celsius, now water will have water will vaporize more, and more amount of water vapors will be formed. The pressure exerted by this water vapors at 100 degrees Celsius will become equal to what pressure? Atmospheric pressure. Therefore, we say water boils at what temperature? 100 degrees Celsius. It doesn't mean that water vaporizes only at 100 degrees Celsius. As we understood, water vaporizes even at what temperature? Room temperature. But only at 100 degrees Celsius, what happens is the vapor pressure of the water becomes what? Equivalent to what pressure? Atmospheric pressure. Since the vapor pressure of water becomes equal to atmospheric pressure at 100 degrees Celsius, we call the boiling point of water to be 100 degrees Celsius. Did you understand what is boiling point? Did you follow?
Yes, sir.
Now, we'll have to understand what is elevation in boiling point. We will understand what is elevation in boiling point now. Now, what the boiling point of a pure water is represented by T0 degrees Celsius. How do we represent the boiling point of a pure water? Boiling point of a pure solvent. It can be any solvent. Pure solvent is represented as T0 degrees Celsius. T0 degrees Celsius. All right. This is the boiling point of a pure solvent. Now, what we will do is, instead of talking about the solvent, we'll talk about the solution now. Now, we will take water, and to this you add glucose. To this you add glucose. How much of glucose you're adding? You're adding 1 mole of glucose. 1 mole of glucose is 180 grams. Molecular mass of glucose is 180. So 180 grams of glucose will be called as what? 1 mole. Now it becomes what? Glucose solution. When you say glucose solution, before we talk about this glucose solution, we will try to understand the boiling point of pure water is 100 degrees Celsius. Boiling point of water. And that is represented in general, we represent for any solvent as T0 degrees Celsius, and boiling point of pure water is 100 degrees Celsius. Now, what we have done is we have taken water, we've added 1 mole of glucose, and we are trying to estimate the boiling point. We are trying to estimate the boiling point. That means at what temperature the vapor pressure of the solution becomes equal to the atmospheric. We are checking. When we check the vapor pressure of the solution, see vapor pressure, the boiling point of the solution is represented as T degrees Celsius. How do we represent boiling point of a solution? T degrees Celsius. Now, for this water glucose solution, when we measure the boiling point, the boiling point is observed to be 100.52 degrees Celsius. 100.52 degrees Celsius. Now, see here, same amount of water was taken in the earlier case. When we check the water, pure water boiling point, it's the same amount of water we have taken. Pure water boils at 100 degrees Celsius. For the same amount of water, when you add 180 grams of glucose, it becomes 1 molar solution. When we check the boiling point is observed to be 100.52 degrees Celsius. When we say it's observed to be 100.52 degrees Celsius, is not the boiling point increased? Is not the boiling point increased? Is not the boiling point increased? For pure water is 100. For the same amount of water and glucose 180 grams, the boiling point is what? 100.52. Is the boiling point increased? Yes or no?
Yes, sir.
Yes. Now, what is this elevation in boiling point? This elevation in boiling point is represented by a letter delta TB. Delta T stands for change in temperature. B stands for boiling point. What is this boiling point? The elevation in boiling point is represented by the formula T minus T naught. Here it's mentioned as T naught minus T. It is T minus T naught. The boiling point, elevation in boiling point is T minus T naught. What is this T? T is nothing but the boiling point of the solution, and T naught is the boiling point of a pure solvent. Always remember, in case of elevation boiling point, T will be greater than T naught. Boiling point of the solution will be greater than boiling point of the pure solvent. T is greater than T naught. So it is T minus what? T naught. So delta B, TB is equal to T minus T naught. What is this definition now? For elevation boiling point, how do you differentiate? Elevation and boiling point is defined as the difference in boiling point of a solution to that of boiling point of its pure solvent is called as what? Elevation in boiling point. Did you understand the definition for elevation in boiling point? Elevation in boiling point is defined as the difference in boiling point of a solution to that of a pure solvent is called as what? Elevation in boiling point. We will understand this now. Boiling point of a liquid may be defined as temperature at which the vapor pressure becomes equal to atmospheric. I taught you that is 760 millimeters of mercury. Since the addition of non-volatile solute, here we have added glucose. Glucose is a non-volatile solute. When glucose is added, a non-volatile solute, what happens? Vapor pressure of the solvent solution always has what? Vapor pressure, lower vapor pressure. We know that we have learned in the previous classes, boiling point is inversely proportional to what? Vapor pressure. See, when you add glucose, what happens? Vapor pressure decreases. When vapor pressure decreases, what happens? The boiling point increases. See, a solution has lower vapor pressure than the solvent, and hence it must be heated to a higher temperature to make its vapor pressure equal to atmospheric pressure. With the result of the solution boils at high temperature than the pure solvent. So all this is theory part which I have explained. So boiling point of the solution will be greater than the boiling point of the solvent. See, this elevation and boiling point is also a colligative property, a property of a solution which depends on the number of solute particles, which depends on the number of solute particles. So when you add glucose to water, what happens? The number of solute particles increases. Since the number of solute particle increases, what happens? The boiling point also increases. if T is the boiling point of a solvent, oh, they have taken the representation like this. Since they have taken the representation like this, okay, their representation is also right. So since they've taken T is the boiling point of a pure solvent and T naught is the boiling point of a solution. So T naught is the boiling point of a solution. So this representation is also accepted. But in your 11th and 12th, they represent it this way. Boiling point of a pure solvent, they take it as T naught, and boiling point of the solution, they take it as T. So this is the right way for you to represent in your exams. T minus T naught. T is the boiling point of the solution, and T naught is the boiling point of a pure solvent. So elevation and boiling point can be determined by various factors. Methods. One is Landsberger's method, Cottrell method. Study of elevation and boiling point of a liquid in a non-volatile solution is known as ubilioscopy. I already told you that elevation and boiling point is also called as ubilioscopy. It's also called as what? Ubilioscopy. Now, important relation concerning elevation and boiling point. We have to learn few formulas to to work out the elevation in boiling point. Elevation in boiling point is directly proportional to lowering of vapor pressure. We learned yesterday, I think we worked on the problem also. Delta TB is directly proportional to relative lowering of vapor pressure or lowering of vapor pressure. P naught is the vapor pressure of a pure solvent. P is the vapor pressure of its solution. We have been learning this in the previous classes. So delta TB is directly proportional to lowering of vapor pressure. First formula. Second formula, delta TB is Kb into M. What is this Kb? This Kb is called as molar elevation constant. Kb is called as molar elevation constant, and small letter m is called as molality. Small letter m is called as molality. What is this molar elevation constant? Now we have learned this. Pure water boils at 100 degrees Celsius. You take 1 kg of water and check the boiling point, it's 100 degrees Celsius. Here you take, in the solution, you take 1 kg of water and you add 180 grams of glucose. Then the solution becomes what? 1 molar solution. Molality means weight of the solvent in kgs. It's not volume of the solvent. It will be based on weight. So water, you're taking 1 kg and you're adding 180 grams of glucose. Then the concentration of the solution becomes 1 molar. The elevation and boiling point of 1 molar is 100.52 degrees. 100.52 degrees. So what's the change in temperature, elevation and boiling point? Delta TB will be equal to boiling point of the solution is 100.52 minus what's the boiling point of water? It is 100. So therefore, elevation and boiling point is 0.52 degrees. This 0.52 degree is called as molar elevation constant for water. It's called as what? Molar elevation constant for water. See here clearly, delta TB is equal to Kb into M. What is Kb? Molar elevation constant. What is this molar elevation constant? The increase in boiling point observed. The increase in boiling point observed when 1 mole of non-volatile solute, 1 mole of non-volatile solute is added to 1 kg of the solvent. I told you we take water 1 kg and add 180 grams of glucose. When we add 180 grams of glucose, the increase in boiling point was what? 0.52 degrees. Increase. Water boils at 100 degrees and the 1 molar glucose solution boils at what? 100.52. The difference in temperature is what? 0.5. This value is called as molar elevation constant. This molar elevation constant varies from solvent to solvent. So water it is 0.52 degrees. For benzene is 1.86 degrees. So it depends upon the solvent. Did you understand what is molar elevation constant and the relation between molar elevation constant and elevation in boiling point? These two formulas, can you remember? People are there and the students, can you remember? Can you hear me?
Yes, sir.
Yes, sir.
This formula, the third formula is delta TB is equal to delta TB is elevation in boiling point. Delta TB is equal to 1000 into Kb. What is Kb? Molar elevation constant into W, weight of the solute, divided by M, molecular weight of the solute, into weight of the solvent. Capital W is weight of the solvent. This is small w is weight of solute. Capital W is weight of solvent. And small letter m is molecular weight of solute. So we can find the molecular mass of the non-volatile solute by using elevation and boiling point formula. Delta TB is equal to 1000 into Kb into W divided by m into W. So what will be m? M goes here to left, delta TB comes here. So this formula based problems will work. So three formulas I told you to remember, I taught you here. One is delta TB is proportional to P naught minus P, and delta TB is equal to Kb into M, the second formula. The third formula, this is delta TB is equal to 1000 into Kb into W divided by M into W. Now, what is Kb? Kb is molar elevation constant. I defined this as the elevation increase in boiling point produced when 1 mole of a solute is added to 1 kg of the solvent. I taught you this. W, small w is weight of the solute, and capital W is weight of the solvent. M is the molecular weight of the solute. I taught you this now. The fourth problem, the fourth formula is Kb is equal to 0.002 into T naught the whole square, T naught square divided by LV. What is this T naught? Normal boiling point of pure solvent. Normal boiling point of pure solvent. LV is latent heat of evaporation in calories per gram of pure solvent. What is this? Kb is elevation and boiling point. We know that. All right. So latent heat of evaporation in calories per gram. What is this latent heat of evaporation? The temperature required to increase, the energy required to increase the temperature by 1 degree is called as latent heat of evaporation here. So it is it's in calories per gram. This is the fourth formula you should remember. This formula we are not learning in our regular class. In the 11th, 12th, this formula is not taught, it's not learned, but remember to work out some of the problems in the competitive exams. Now, we will solve some questions based on this, and then we will continue with the next colligative property. Now, elevation and boiling point, that's all is elevation and boiling point. It's a simple topic. If you have any clarification with elevation and boiling point, please tell me. Quickly, elevation and boiling point, if you have any clarification, you can ask me. Please talk to me.
No, sir, no doubt.
No, sir.
All right, you're able to follow.
Yes, sir.
Yes. Now, elevation and boiling point, some of the questions, there are many questions to be solved. I think then we'll go for the next topic. If 1 gram of solute, molar mass is 50 gram per mole, molar gram is 50 gram per mole, is dissolved in 50 grams of solvent, and the elevation in boiling point is 1 Kelvin. Elevation in boiling point is 1 Kelvin. The molar boiling constant of the solvent is. Molar boiling constant of the solvent is. Molar boiling constant is also called as molar elevation constant. So we know that delta TB is equal to Kb into M. What is Kb now? Kb will be molality by what? Molality by delta TB. They have not given molality directly. Is it correct? No. Kb is what? Delta TB by M. Sorry, delta TB by M. They have not given delta TB directly. They have given delta TB. That's increase in, delta TB. Elevation and boiling point, they have given us what? 1 Kelvin. So that will be 1. Molality is not given directly. So how do you calculate molality? Molality, they have given 1 gram of solute. The molecular mass of the solute they have given us 50. So therefore, it will be 1 divided by 50. 1 divided by 50 is nothing but number of moles of the solute. Into, they have given 50 grams of solvent. But normally, molality is considered for 1000 grams. So 1000 grams divided by 50. So if you simplify this, you will get 5 by 2, and you will get it as 2.5. So the delta Kb value or elevation in constant is 2.5. Did you understand this? Molality is given by the formula N into 1000 by weight of solvent. Remember, this is how one of the formula to calculate molality. M, small letter m. N is number of moles into 1000 divided by weight of solvent. So number of moles is what? Weight in grams by molecular mass. Weight in grams, they were given 1 gram, and molar mass they were given as 50 grams. So 1 by 50 into 1000 by 50. You understood this problem?
Yes, sir.
Understood?
Yes, sir.
Yes. Yeah. All right. All right. The next problem. A solution containing 12.5 grams of non-electrolyte. Non-electrolyte means which does not dissociate nor associate, which will not give ions. Those are called as non-electrolyte. So 12.5 grams of non-electrolyte substance in 185 grams of water. 185 grams of water shows boiling point elevation to be 0.80 Kelvin. Calculate the molecular mass of the substance. They are given Kb as 0.52 Kelvin per kg. Given Kb as 0.52 Kelvin, kg per mole. Unit for elevation constant is kg, Kelvin kg per mole. Remember this, Kb. Now, what's that they're asking? They're asking you to calculate the molar mass of the substance. Now, molar mass of the substance, we will take molar mass of the substance to be m. That will be equal to Kb into Wb divided by weight of the solute into Wa. What does the B stands for? B stands for solute and A stands for solvent. So delta, Kb they have given us 0.52, and Wb, weight of the solute, they have given us 12.5, and delta Tb, they have given it as 0.80. Increase in boiling point or elevation in boiling point is given as 0.08 Kelvin. The weight of the solvent, they have given us 185 grams. So on simplification, you will get, you cannot take, maybe I'll work this formula in few minutes time. We will see what can be done. I'll give one more formula also. This formula we learned. 1000 kb by W divided by MW. This formula you remember, we'll solve that also. 1000 delta TB is equal to 1000 kb into W divided by M into W. So or else we can write M is equal to what? 1000 kb into W divided by delta TB into W. Now just observe this formula you can also use. This also is right. Oh, where I'm using? Oh, I'm not using it in this question. Sorry. Yeah. Delta TB is equal to 1000 kb into W divided by M into capital W. So what will be M? M will be equal to 1000 kb into W divided by delta TB into capital W. Now you substitute here 1000. What is Kb? Kb they have given us 0.52 into W, weight of the solute they've given 12.5. The question they've given 12.5 divided by, better use this formula, divided by delta TB is 0.80 into volume is 185. If you simplify this, the answer what you will get is 43.92 gram per mole. The answer for this question is 43.92. Here, the same formula, see, they have not mentioned the 1000 here. Since they have not mentioned the 1000 here, you cannot take volume in terms of grams. You have to convert the volume of the solvent in liters. When we convert volume of the solvent in liters, 185 ml is equal to 0.185 liters. So here you have to convert it in liters. Since we are not taking 1000, if you take 1000 grams, here also you can maintain it as what? 185 grams. And this answer also, if you simplify, this also will be what? 43.92 gram per mole. Both will give you the same answer. So I prefer you to use this only. 1000 into kb into W divided by delta TB. This is little confusion. Only confusion is you have to take the weight in liters here. Here you cannot take weight in liters. Here it is 12.5 grams, you take it as 12.5 grams. Solvent, this WA is weight of solvent. Solvent, in case of molality, it is in kgs. This is in kg. Sorry, this is in kg, not liters. 185 ml is what? 0.185 kgs. Solvent has to be taken in kgs. Mass of solvent. I wrote it as volume by mistake. Sorry, it is mass of solvent. Because we're talking about molality. Molality is in terms of what? Kgs. So mistake. I made a mistake here. It is mass of solvent. Followed? Yes?
Yes, sir.
Yes. Yes. The next question. Now, 0.15 gram, if 0.15 grams of solute dissolved in 15 grams of solvent is boiled at a temperature higher by 0.216 degrees Celsius than that of a pure solvent, the molecular mass of the substances. Is the same question. They have framed it in a different way. What is the formula? Elevation in boiling point is given by the formula what? 1000 into kb into W divided by M into what? W. Now, what all is given in the question? Given W is small letter W is 0.15 grams. Capital W, weight of the solvent, it is 15 grams. And they've given you elevation in boiling point. See this? It's boiled at a temperature higher. So delta TB is equal to 0.216 degrees. And molar elevation constant also they've given us 2.16 degree Celsius. So what they're asking you to calculate, molecular mass M. So what will be M? M will be 1000 into kb into W divided by delta TB into W. So that will be equal to 1000 into, what is kb? kb is 2.16 and small letter W is 0.15 divided by delta TB is delta TB is 0.216 and what is W? 15 grams. So it's a simple simplification. All right. So if you simplify, this is how many times? This will be 10 times. And this will be again 10 times. And this also will get cancelled. Correct. This also will get cancelled. No, not 10 times. This 100 times, I think. 0.15. This is 15, no? Yeah, 100 times. So what happens? 100 times means the this will get what's that? Wait for a minute. I'll erase this. So this is 0.15 and this is 15. So this is 10 times and this is correct. No, this is 0.1. Yeah. So you will, on simplification, I think this is 100. This is also 10 times. This 100 times, I think. Yeah, this 100 times and this is 10 times. So this will be again what? 10. So this will be again what? 100. Cancel. So therefore, you will get the molecular mass to be 100. So the answer for this question is 100. You can check the simplification. You can check the simplification later. So the answer for this question is 100. Molecular mass. It's all direct substitution in the formula. So few of the questions we will have to learn, wherein you have to apply the understanding of the subject. See this question, it's not a direct question. It's a little different. At 100 degrees Celsius, the vapor pressure of the solution of 6.5 grams of solute in 100 grams of water is 732 millimeters. 732 millimeters. If Kb is 0.52, the boiling point of the solution, they are given vapor pressure here. They have not given anything. Since vapor pressure is given, it is possible for us to calculate the molecular mass. How do we calculate the molecular mass? We know that P naught minus P divided by P naught is equal to WB into MA divided by MB into WA. A stands for solvent and B stands for solute. That's all. So what will be MB? MB will be equal to what's that we can write, or else maybe MB, if you can write, it will be WB into MA divided by WA into P naught minus P naught divided by P naught minus P. This is the formula. So on substitution, what is WB? W weight of the solute, they've given us 6.5. See, they have not given the molecular mass of solvent, but they've given solvent as water. What's the molecular weight of water? It's 18. Divided by, what is WA? Weight of water they've given as 100. Into, what is P naught? Now you have to remember, 1 atmospheric pressure is 760 millimeters of mercury. 1 atmospheric pressure. Standard pressure, 1 atmospheric pressure, 760 millimeters. So that means P naught is 760 divided by 760 minus, what is P? They have given 732. So on simplification, the molecular mass, you will get it as 30.6. 30.6. So we have to find the molecular mass using relative lowering of vapor pressure, because they have given you what? Vapor pressure. Once you're done with the molecular mass determination, then we can calculate the boiling point elevation. They're asking the boiling point of the solution. Now we should know that delta TB is equal to Kb into molality. This formula you know. So delta TB, Kb they have given us 0.52. What is molality? Molality we calculate weight of solute, number of moles, that is 6.5 divided by 30.6 molecular mass. Solute they've given us what? 6.5 grams of solute. And molecular mass we found out here is 30.6 into 1000 grams divided by weight of solvent they've given us 100. That will be simplification, you will get 1.10. The answer what you get is 1.10. Therefore, what is the increase in boiling point? Boiling point increase will be 100 plus 1.10. That is 101.10. So therefore, the answer for the question is approximately 101 degrees. So it is option D. Check this problem, and any clarification you can ask me quickly. Go through this problem and you can ask me.
No doubt, sir.
Yeah. Any others? Any clarification? No clarification. The next problem. The next problem is the boiling point of water at 750 millimeters of mercury is 96.36 degrees Celsius. How much of sucrose is to be added to 500 grams of water such that it boils at 100 degrees Celsius? Molar elevation constant they have given us 0.52 Kelvin kg per mole. Elevation in boiling point. What is elevation in boiling point? Delta TB is given by the formula T minus T naught. They have given delta TB, they have given us water, T minus T naught. Boiling point of water at 750 millimeters of mercury is 96.63. And what is that they have given? Its boiling point of pure water is what? 100 degrees. 100 minus 96.63. That is equal to 3.37 degrees Celsius. Elevation in boiling point is 3.37 degrees Celsius. What is the weight of solvent they have given? Weight of solvent, W1, they've given us 500 grams. Excuse me, 500 grams. What is the molar mass of the solvent? molecular weight of solvent. Solvent is water. Remember, water, the molecular mass is 80. What's the molecular weight of the solute? Solute is sucrose. What's the molecular mass of sucrose? C12H22O11. So this is the molecular formula of sucrose. Remember, molecular weight of sucrose is 342. 342. All right. So elevation in boiling point, they have given elevation constant, molar elevation constant. Kb they have given as 0.52 degrees. Kelvin per kg per mole. Kelvin kg per mole they have given. And they're asking to find the weight of the solute to be added. They're asking weight of solute to be added. This is the question. In order to do this question, we know that delta TB is equal to 1000 into KB into W divided by M into capital W. So from this, we can calculate the weight. So what will be weight? This weight we want, weight of the solute, small letter w, that will be equal to delta TB into molecular weight into capital W divided by 1000 into KB. So what's the molecular mass? Delta TB is 3.37, we found out. Molecular weight is 342 of sucrose. Weight of the solvent, they've given us 500 grams, 500 divided by 1000 into what is the weight of, what's it? This is KB, sorry, this is KB. So KB, what is that KB they've given? 0.52. So on simplification, you will get 1108.2 grams. 1108.2 grams. Hence, the answer for this question is option B. It's a direct question. Did you follow this?
Yes, sir.
Yes. The next question. .15 grams. This we did, This we did. This we did now. The same problem we did. So I am not teaching you this. I think I retyped this again. Same values. Yes, we did this. We did this. So it's a repetition. All right. Let's see. It's a repetition. So it's 100. We learned it. It has to be 100. This question is here. See here. Where is that? Here, 100. Same question we did. Yeah. Again, I retyped. The next question will go. The rise in boiling point of a solution. The rise in boiling point of a solution containing 1.8 grams of glucose in 100 ml of solvent is 0.1 degrees Celsius. The molar elevation constant of the liquid is. So we know the definition, relation, delta TB is Kb into M, molality. They're asking you to calculate the molar elevation constant. In order to write the molar elevation constant, calculate, we need to know the molality. How do we calculate the molality? Kb into molality. What's that formula we give? What's the formula? Molality. It is 1000 into W divided by molecular mass into weight of the solvent. This is the formula to calculate molality. 1000 into weight of the solute divided by molecular weight of the solute and weight of the solvent. What is given? They have given, so maybe we want a delta, if we want Kb, right? So Kb will be what now? Kb will be equal to, Kb will be equal to delta TB into M into weight of the solvent divided by 1000 into weight of the solute. So delta TB they have given, the elevation is what? 0.1. Delta TB is 0.1 degrees Celsius. What's the molecular mass of the solute? The solute they have given glucose. Glucose is C6H12O6. The molecular mass of glucose is 180. You should remember. It's 180. What's the weight of solvent they've given? Weight of solvent they've given to be 100 divided by molecular mass. Weight of solvent they've given divided by 1000 into what's the weight of solute? It's 1.8 they're given small letter w, 1.8, 1.8. So on simplification, we will get the answer to be 1. So the molar elevation constant of the liquid is 1. What is this? If you understood, you tell me what is this molar elevation constant? Is 1 means molar elevation constant is 1 means what? Tell me. If you add 1.8 grams of glucose to 100 ml of water, the increase in boiling point will be what? 1 Kelvin per kg per mole. That is what molar elevation constant means here, kb. I hope you followed. Yes?
Yes, sir.
Before we go
Yes,
for
sir.
the next, I don't think so. We will continue with the next elevation, the colligative property now. This next colligative property is similar to elevation and boiling point. Only thing there is what? The temperature will decrease, depression and freezing point. Here there is an increase. There, when you add a solute, what happens? The freezing point will decrease. That is the only difference. But otherwise, the mathematical formula, the calculations, all that will be same. Similar relationship we will be learning. Anyways, we will learn that also, and we will learn the questions possibly in the next class. Theory I will teach you because we have 10 minutes time. Depression and freezing point of the solvent, it's also called as decrease in freezing point of the solvent, called as cryoscopy. So decrease in freezing point, or it is also called as what? Cryoscopy. Now, what is this depression in freezing point? Now you take water. This water freezes at what temperature? What's the freezing point of water, pure water? What's the freezing point of pure water? What's the freezing point of pure water? I've written it. It is what? 0 degrees Celsius. This is pure water. We will mark it as what? T0. We'll mark it as T0. Now, the same amount of water I take, same amount of water, to this, I am adding a solute, non-volatile solute. And I check that for water is 0 degrees, I check the freezing point. The freezing point of solution will be minus 0.52 degrees. I add 1 mole of water, 1 mole of solute. So 1 molar solution I'm taking. So the freezing point decreases minus 0.52. There's a decrease in freezing point. So this decrease in freezing point is given by the formula delta TF is equal to T0 minus T. It is not P0 minus T. There's a mistake here. This is T0 minus T. So delta TF is T0 minus T. See, freezing point of pure water minus what? Freezing point of its solution. So here in this case, it will be what? 0 minus of minus 0.52. That will be equal to 52 degrees, 0.52 degrees. All right. So you should remember, whenever a solute is added to a solvent, the freezing point of that solvent will decrease. That decrease in freezing point of solvent is called as cryoscopy. So this is an important question. Remember, depression in freezing point is determined by Beckmann's method. This Beckmann's method, you remember. Rast-Camphor method we don't study, but Beckmann's method is for you to remember for some exams. Study of depression and freezing point of a liquid in which a non-volatile solute is dissolved is called as cryoscopy. I taught you this. All right. So depression and freezing point is directly proportional to lowering of vapor pressure. Oh, they've given, this is one of the relation we are talking about. All right. Then it's right. Lowering of vapor pressure, like boiling point we spoke, no, same thing, they've given the relation. Delta TF is directly proportional to lowering of vapor pressure. But what is the actual formula to calculate the depression and freezing point? Delta TF is equal to T0 minus T. And the second formula is delta TF is Kf into M. What is Kf? Molar depression constant. What is this molar depression constant? In elevation constant, it was Kb into M. In depression constant, it's Kf into M. What is Kf? Kf is called as molar depression constant, or There was some net. Can you see the screen? Hello, ma'am. Ma'am, make me a host. Hello, ma'am. Hello. Hello, ma'am.
Yes, sir.
Make me a host, ma'am.
Yes, sir. Yes, sir. Thank you, sir.
Wait. Okay, ma'am. I'll stop the class, ma'am. Tomorrow I'll continue. Okay.
Okay,
bye.
sir. Okay. Thank you, sir.